We're here to talk about discovering rapid 3D design exploration with ANSYS AIM and ANSYS Discovery Live. Real quick, before we get started, I want to briefly introduce EAC. If you're not familiar with us, we are a product development partner for companies in almost every industry, working to transform the way those companies design, manufacture, connect to, and service their products. Our range of products ranges from CAD and PLM software to simulation software like ANSYS that we're going to talk about today, as well as 3D printers. And then on top of those products, we have a variety of IoT and augmented reality implementation services, wind chill implementation, and also custom design engineering services, and also training on all of the products that we support. So over the past few years, we've been deepening our relationship with ANSYS in order to bring world-class simulation software to the market. And as a result, our customers are taking advantage of that software to speed up their design process, improve the quality of their designs and iterate through those designs very rapidly, and ultimately build better products. And that's what it's really all about, and that's what we're here today to learn how to do that a little bit better. So with that, I'll turn it over to Todd, our technical account manager, who's going to walk us through rapid 3D design exploration with ANSYS AIM and ANSYS Discovery Live.
So we're going to talk about the ANSYS Discovery product family. I'm going to show a few slides about the technical details about these products, and then I'll go ahead and show a number of demonstrations after that. So we're here to talk about Discovery Live version 19 and also Discovery AIM for version 19. So these both come as the foundation. They come with a geometry modeler. They come with Discovery Space Claim. And then you can go ahead and get Discovery Live in the middle there, or even go to all the way to the top up here, Discovery AIM, where you would have all those three combined together. Again, all these three products are all based on ANSYS's 40 years history of analysis software. They're built on the experience, the flagship products that customers across the world all rely on every day. But now they're available to users with a much easier to use interface and also real-time simulation, which is the one we're going to talk about first. It's called ANSYS Discovery Live. This is super fast analysis, easy to use, geometry enabled, real-time simulation. There's no meshing, there's no post-processing. It goes ahead and solves it automatically, and then you're going to see the results right away. So your benefits are here, just simple, no learning curve. Really, you're up and running right away. And it does requires a little bit of a graphics card that you need in your machine. Otherwise, very, very easy to stand up. So I think I'm going to show that first here. Before I show any slides for Discovery AIM, I'm going to come back to this. So I'm just going to go ahead and first just show Discovery Live. This is ANSYS Discovery Live. There is a little start page here that has a number of example models I like to just show because they're quick and easy here. So let's go ahead and grab this little dump truck here. And the kind of physics that we can solve, we can do fluid analysis, both external flow and internal flow. All I have to do is, in some of my models, I have to do this again, excuse me. Sometimes if I leave my machine kind of stagnant for a minute, I have to restart some stuff. So apologize, let me start that again, and then things will all flow nicely. Like I said, you can do structural analysis, thermal, also fluid flow, both internal and external flow. So we'll just go ahead and start from very scratch here. And once it starts up, we'll start with that little dump truck example. It's going to be an external flow, sort of like a wind tunnel example. There it is. So we'll pick on that truck again. It loads the geometry for us. And then all we have to do is say create a solution. And we're going to do a fluid analysis. And the fluid's going to be air. And we'll say external flow. And we just have to tell the direction and then where the floor is. And then again, no meshing, real-time simulation. Here's our fluid analysis right away for you. And like I said, this is real-time. This is a 3D transient fluid analysis. If we want to look at this example here and turn off our plane, notice it is a 3D analysis here, okay? Let's turn our plane back on. We'll see just half of it here. And just to go through a few of the options here, you can do streamlines is one way you can do it. Turn that off there. Okay, we can look at the streamlines as they're moving over the truck here. You see the truck's not too aerodynamic. You can also look at the particle flow here. And it's also nice to look at the particle flow if you're living in Minnesota. There's your snow. And you also have an emitter here where you can actually look at the fluid as it comes up and over the truck there with a emitter type of analysis there. And then lastly, there's another cross-sectional flow here you can look at as well. Again, all giving you different views at how the fluid analysis will work in this analysis. Now, like I said, it's real time. So if I picked on a surface like this and just drag that up, we have instantaneous results, right, as you're doing this. Okay, if I wanted to grab this entire truck here, for example, and go ahead and move this, I can go ahead and copy that and make 2 trucks if I wanted to. And again, real time, here's my simulation of 2 trucks, what that looks like. Look at my streamlines here, move that in the middle here if I want to look at what kind of turbulence is happening in the middle there. So it's all real time, all very simple, easy to use. Let's go ahead and close that. Just to also show you that if you want to do like a little more aerodynamic model, let's go ahead and grab, I think it's this one. Yeah, here we go. Again, we'll do the same thing, fluid analysis, external flow, what's the direction, and where's the ground. And here's our car, okay. Very simple. Again, you ask somebody else to try and do a wind tunnel type of simulation, and you're going to be waiting much longer to get any kind of results. Let's go back to here. Let's do a structural analysis this time. Let's grab this little bracket. This time we're going to come again. Here's your fluid, thermal, structural, modal. We'll do structural. You can pick from a number of different materials, okay, that are built in. You can also make up your own materials. Let's say structural steel. Hit create. Let's pick on these 2 surfaces for our fixed support and go over here for our force. And we're going to go ahead and just put that as 0 and tab that up to the Z value, I'll say 100 newtons in the positive Z. And here's our solution. Again, no meshing, instantaneous results. Okay. And if we wanted to, change some geometry, we can also put on a number of different things. I can put stresses on a volume, for example, a chart. There's a number of charts you can do here, up here, based on what kind of analysis it is. If I was doing a thermal or a fluid analysis, I'd have different things like pressures or velocities or temperatures. But I can chart lots of different things. And the reason this is called Discovery Live is it's trying to make it so that you don't have to spend a lot of time and meshing and solving and looking at comparing them. You want to make real-time decisions here. So I can pick on this surface here. And let's just move it down a little bit. What if we move it like that? Does that make the stress of my model go up or does it go down? And then I have over here that looks like it goes down. Okay. Or we could go here and turn off our geometry here, and let's just do a fill here on this one, and let's see if that causes our stress to go up or down based on that change. And it looks like it's still going down. Okay. I can also pause this, and I can come in here and maybe sketch a number of things here. Not sure what this geometry will look like. Let's just see. Let's do something like that. Like that. And then it's just drag that geometry out like that. Then we'll resume after we do that. Does the stresses go up higher or lower? We'll probably get some stress risers there because we have some edges that have to be moved. Let's go ahead and make that around right there. What happens then? Does our stress go down or higher? Looks like it stays pretty close to the same. So that's the kind of thing you can do. You can just play with geometry, build dozens and dozens of prototypes, and try to get the best design you can. So that's what I wanted to show you on the live side. Again, here at EAC, we're excited to take any kind of examples you have and show you those specifically to what you're doing. So we have John, who's on the phone as well, and then also another salesperson that would like to work with you. Just give EAC a call and we will work with you to see if live can really have an impact on the number of iterations and the quality of the designs that you're working with right now. So let's go ahead and end the live portion and go back to a little PowerPoint on Discovery AIM. Okay, Discovery AIM is a desktop solution tool that has meshing and it has post-processing, has those types of features. Doesn't do it real time, but it has a ton of functionality. It's really sold and delivered as a multi-physics tool. If you look at this little wheel here, we have fluid flow, heat transfer, fluid structure interaction, electric conduction, stress analysis, and all those can be combined. So you can do a number of different physics all together in one simulation. There's an integrated geometry modeling. This again is a space claim that lets you bring in any kind of geometry from whatever source you have. Okay, bring those native geometry in. And AIM also has a geometry interface too, so you can actually bring over parameters and name selections from those different CAD products if you wish to. Okay, so easy to get the geometry in, and then the very robust and automated meshing. They made it very simple for people to use for meshing purposes, and all the numerical knobs that you would get in the flagship ANSYS products, many of those numerical knobs are there to move for changing the different mesh settings appropriately if you'd like to. Fluid performance, so steady state, laminar, turbulent, compressible or incompressible flow, and lets you get all kinds of coefficients, lift and drag, pressure drop, okay? And then also you can pass those fluid loads over to structures as well. So you can combine fluid and thermal together, even fluid, thermal, and structural together. You can also do some particle tracking as well on fluid performance. So a ton of functionality is there for people. The most, I guess, most common things that people want to do with fluid analysis is here. There's also structural analysis, both for large assemblies, for piece parts, some rigid connections functionality, and also a very comprehensive contact analysis. So all the same contact that you're used to on the ANSYS flagship products and mechanical are here as well. It also includes deformation too, or large deflection. That tab is exposed inside of AIM, so you can actually use that too. So that's part of a structural portion. And then thermal, you have thermal stress, you have radiation, convection, thermoelectric, if you want to combine those. And then, like I mentioned before, when it comes to multi-physics, you won't find an easier solution anywhere to combine. For example, in the top right, you have wind and structural loading together. Okay, thermal and thermal stress together, fluid flow and stress together. Very simple for internal and external flows. DC electrical portion as well. There's also an electromagnetics section of ANSYS AIM. Tons of different ways of visualizing results. You can see if the Tom Brady, football scandal last year, actually 2 years ago now, really was a big deal or not. And any kind of streamlines, computed measures, all those are available inside of ANSYS. And also design exploration. You can parameterize a number of different types of things like loads, results, and then you can look at different combinations of those inside of AIM. And lastly, there's automation and customization. You can build up AIM to solve from scratch. You can go ahead and just go through the templates, the predefined templates, but you can also define your own templates and your own workflows. If you do all kinds of valves every day, and you could very easily just record that through the Python scripting and make that into its own customized template. So it's easy to make your own wizards inside of ANSYS AIM. All right, so that's the few things I wanted to show on ANSYS AIM. Let's go ahead and let's start from scratch here on this one. So here we have the ANSYS AIM landing page. You can see you're going to pick from a number of predefined templates. I'll pick on the structural one here. And then I'll go ahead and hit next. And I like to say sometimes it's like TurboTax, even though we're past the tax day here. Made a lot more sense back in, before April 15th. But it asks you a number of questions, and you're going to answer these questions with respect to what you want to do, which kind of physics do you want to include. And the more things you check, then the more questions you're asked. Okay. I'm going to pick on some geometry. And then again, we're going to say it's going to ask you, do you want to include thermal? Do you want to include electric conduction? Do you want to do modal? Do you want to have fatigue results at the end? I just answer those questions. There's some predefined answers, some default answers, and then I say, okay. Then it builds my workflow on the bottom for me. So I'm going to call it a mesh next. I just go from left to right, click on the blue lightning bolt there, and it gives me a default mesh. Okay. Now, if I'm not happy with that, I can go ahead and just uncheck the predefined settings here, and I could add maybe a size control, maybe a body sizing or face size. Let's do that there, and then I can say, well, element size. What am I in inches? 0.1 inch. It's meters, I'm sorry, 0.05. There's our size element there, and let's go a little smaller, like 0.002, okay. And then let's go ahead and just update that. Notice how big those elements are in there at the start, and now we made those elements a lot smaller in there. And we can change the type of elements too, but let's just leave it like that. Let's go to physics is next. And I'm just going to pick on a couple of surfaces here and say those are our supports, and pick here. And this is going to be our force. So very similar to how we did it in Discovery Live. I'm just going to give it a value here in the Y direction, like that. Once we have all yellow here, we can go ahead and solve it. But just to expose, here's materials. That's there's a number of different materials inside of here. There's our interfaces for our contact. But let's just go ahead and right click here and say evaluate results. So it's going to use traditionally, now it's using the mesh, it's going to solve it and then expose the results to us. It has a couple of predefined ones in there for deformation and equivalent stress. So once it's complete, we can look at those and make an evaluation if we have to change our geometry or not. But like Discovery Live, it gives us very quick answers, not final answers, but very quick and good answers. But Discovery AIM is going to give you solid final answers. That's the difference there. Okay, here we have stress. If we want to look at displacement, there's a displacement. You get some animations as well. Look at the elements if you want to. So great graphics, great visualization, and it's really going to solve for anything in here. If I have beams, bolts, contact, displacement, joints, reaction loads, spring loads, all those things are exposed inside of AIM. All right, so that's a little bit of from start to finish how to use AIM. Now, if you look back at that starting page here, you have structural, fluid flow, thermal, electromagnetics. I've been working with a customer in electromagnetics recently, and they've been very impressed with how it's predicting solenoid forces. Topology optimization as well is built into every seat of ANSYS, whether you're on the mechanical or AIM, topology optimizations there. Here's your fluid structure interaction, heat conjugate, solutions. So let's go ahead and show you a couple of other solutions that have been done already. Here's a topology optimization one. We start with the with a plate and a couple of bushings. We set up our mesh. We click on optimize here, and we just have a couple of conditions here. We have some displacement or some structural constraints here, and then we have just a force here going in the down direction there. And then we can go ahead and tell it how aggressive or conservative to be, and this is our solution here. If it won't go back to like more aggressive, it's going to remove even more material. That's probably too much there. Back to conservative, we have a little more material there. And then you can take that, it's going to basically just reduce the number of elements in the model, and then we can take it over to space claim and make our faceted model into a solid model, and then we can look at the results like this. And we can validate our design to see if it's going to make a big difference on our stresses or displacement once we remove that extra material that was there. So here we removed over half the material, and we still have a model that's very that validates and will withhold the type of forces that we're exposing on it. All right, so that's topology optimization. Let's go ahead and go next. This is a fluid structure analysis. Just going to show the setup for you. Here's the full pipe assembly we have here. We're going to go ahead and suppress a few things here, just so we're left with the fluid volume at the end here. We're going to mesh the fluid volume. Let's look at this in translucent here. There's a butterfly valve in the middle there. That's those surfaces are exposed. We also have some surfaces up here that are exposed. There's a sensor up on top that the fluid flow is going to come across. Okay. This is just the final fluid volume here we're looking at. And then we just set up our flow conditions. We're going to have an input down here at the inlet. Right there, we have a pressure load coming in there. And then we have a couple of, we have an outlet up on top, and then we have a wall, which is every other surface in the model. And then we just run it, and we get results like this. So just look at the streamlines. Here's the streamlines going around that butterfly valve. Let's look at pressure here. Here's the pressures on that butterfly valve. We could even look at the mass flow at the end too. So a function calculator or a calculated value, we can get the mass flow as well. So here you can expose all these things. You can also look at what kind of action or result is going to be on the structural portion of this as well. So now we go ahead and just go back to just the sensor. We mesh the sensor, and then for the structural analysis, look on the diagram here. The flow results are going to be our structural load. Okay, we just have to define the material for this part here. It's going to be fixed on the side there, And the results are going to be like this, where the stresses are going to be exposed, something like that. So we have the fluid flow coming up here, and then here's the stresses on that sensor. So very easy to do an internal flow coupled fluid and structure analysis. You can also do external flow as well, like a wind loading on a structure, and then get the results as well on that. All right, so that's the stress, and then you can also look at the displacement, which might be something you're interested to find out, how much displacement is going to happen there as well. So those make sense. Let's go ahead and change this other one here. This is a, I like to show this one because it's a nice little example of showing a very complicated contact example. This is a 3D contact example of a coupler that locks together, and you can see that it's only a quarter model to make it a little easier to work with. We just set up a simple problem here. You just set up your displacement on the top to be 10 millimeters. It's going to push in that direction. And then over here, it's going to be fixed. And then we have some symmetry, and that's really all there is to it. Define the materials. And then also we have a contact in here. Okay, so we have a contact in blue and red. That's nice. You can pick a number of surfaces together. You don't have to just pick one surface to the next surface, but you can pick really a combination of all those surfaces that are going to come into contact at one point. So it makes it a lot easier. And then also I want to show this dialog box here. This is a frictional constraint or a frictional definition of the contact. There's bonded, frictional, frictionless, no separation, and rough. Again, pinball, stiffness, normal stiffness. All these are exposed here in AIM. These are all from the ANSYS mechanical product, and they're all here for you to be able to simulate any kind of contact example that you might encounter. And then we have a number of results here. We have the equivalent stress. Let's just look at that one as they come together. And then we also have like a force reaction as well. And that depends on where you're at, to how much force is being put on the model. Okay, so it gives you a max as well. So I believe that's the solutions that I wanted to show you. Let's see if I have any more. I think that's it. So I have shown you the ANSYS AIM product, which covers all those physics together. And also I covered at the start, I covered the ANSYS Discovery Live, which is real-time simulation. And we have packages that combine the two. So you get both of them with one package for a very low cost.